Today we'll be talking about modeling with polynomial functions. This is day 1 of chapter 5, section 9. Now the first thing we're going to look at is how to write a cubic function whose graph passes through the given points on this graph. So what we're going to do is first we're going to write all of the zeros in factored form. So if we have a -6 as a 0, it's going to be x plus 6. And then x plus 3, and then x minus 3. Okay, and this is a function, so it's the f of x. And we need to know our leading coefficient, which we're going to put a, because we don't know our leading coefficient. So if we look at this graph, we have another point on the function, which can be our x and our y, which we can plug into our function. Now remember, our y value is always our f of x, so we can plug in -9 to f of x, keep the a, and then 0 in for all the x's. Okay, and now we can simplify and solve for a. So we have 6, 3, -3, -9 equals a -54a, divide, and we get 1/6. Okay. Now to write our function, we just say the f of x is equal to 1/6 times x plus 6 times x plus 3 times x minus 3. And we have our function written. So let me show you another one of those. Once again, we have a graph with our zeros and another point on the function. So we're going to write those in factored form. So we have x plus 3, x plus 1, and x minus 2. And then we have the f of x equals, and then our leading coefficient a, which we don't know yet, so we have to find. So they give us another point, -2, 4, which is our x and our y. So we're going to say 4 is equal to a. Our x is in -2 plus 3, -2 plus 1, -2 minus 2. So now we have a -2 plus 3, which is a 1, a -2 plus 1, which is a -1, and then a -4. So 4 will equal 4a, a will equal 1, so our function is the f of x is equal to x plus 3 times x plus 1 times x minus 2. All right, and so that's our function. Next up, we're going to use finite differences to determine the degree of the polynomial function that fits the data. Then we're going to use technology to find the polynomial function. So finite differences is finding the difference between the y's. Okay, so we're going to look at our y values, and we're going to keep on finding the differences until all the differences become the same number. So to get to -14, we are going to add 9 to get to -5. To get from -5 to -2, we're going to add 3. -2 to 7, we're going to add 9. To get from 7 to 34, we add 27. And to get to 34 to 91, we add 57. Those aren't the same numbers, so now we're going to find the differences of those numbers. 9 to 3 is a -6. 3 to 9 is 6. 9 to 27 is 18. And 57 to 27 is 30. Okay, these aren't the same numbers, so we're going to do another layer. -6 to 6 is 12, 6 to 18 is 12, and 18 to 30 is 12. All of the differences are the same, so it's 1, 2, 3. It's in our third degree, so that is going to be a cubic. Now that we know it is a cubic, we're going to put this information into our calculator. So I'm going to pull up my calculator, and what I'm going to do is, hold on, I'm going to clear this out. I'm going to go to Stat 1, which is Edit, okay, and make sure your lists are clear. And we're going to put our information into this list. So we're going to put in -1, 0, 1, 2, 3, oops. Go back to Stat 1, Edit. So we have -1, 0, oops, let's try that again. -1, 0, there we go. 1, 2, 3, 4. Okay, and we arrow over and we put in our other information. -14, -5, -2, 7, 34, 91. Okay, once we put in that information, we can use our regression feature, and we figured out it was a cubic regression. So we go to Stat, arrow over to Calc, and we go to number 6, cubic regression, since it is a cubic polynomial. And it's going to be calculate. So what we're going to do is we're going to write our function, which is the f of x is equal to 2x cubed minus 3x squared plus 4x minus 5. So that's how you use your technology in finite differences to write your polynomial function.